Alright, friends, this is pretty much an unplanned video. I'm just going to plunge in. What I want to do is show you some Python and synergetics side by side. What I have in front of my face here is what we in the trade call, well, we can call it a vector flexor. That's kind of a brand actually, but more generally, we call this the Jitterbug transformation. And you can watch YouTubes about it. It's pretty well known. It's in the literature nowadays. It it took a while to get there, but there's a dance quality to it, right? So Jitterbug was like a swing dance at one point, and there's a dancing aspect to this if I can get it to work properly. What I'm going to do is move over to Python here in a second. Let's see, doing it should doing back and forth, but it's been in the box. It's very biased right now to want to only contract in one direction. And I'm trying to get up enough speed. There we went the other way. There we did. Boom. Well, let's try it again. I'm trying to get over the hump. Whoa, whoa. Oh, it's like there. I did it. Jumping over something. So here we get down to an octahedron, and then depending on how you animate it, if it's really made out of wood or whatever, you can get to a tetrahedron. And then the idea here is there's some kind of inside outing, and it kind of pops into negative universe. Never mind what that means. It's just you get to unfold again and the other side of things. So it's kind of like shrink down to zero, turn inside out, and shrink back out again. Shrink down to zero, turn inside out, and come back out again. And this whole pumping thing from like 20 to 20, which is the volumes, think of that as like a bow tie. And that's what Fuller called the bow tie universe. All right, enough hand waving. To the screen. What we have here is a blank canvas. And I'm going to make a generator called Jitterbug. And I'm going to put in like the major station stops, like where we want to start and so forth. So let's start with the cube octahedron of volume 20, and then we shrink down to an icosahedron of volume about 18.51, and then we keep shrinking to, let's go all the way to the octahedron of volume 4, and from there all the way to the tetrahedron of volume 1, and from there we go through zero somehow, cosmic zero. No pause. We don't really stop here. So it looks like we do, but actually I'm going to comment this out. And also I want to talk about a cube octahedron in the middle here, the 2.5. We need a station stop there. And then coming back out, remember it's a bow tie. We're just going to do this whole thing in reverse. And so we're going to come out back out in, we're in inside out universe here. You could say, I just want it to station stop our way back out to another cube octahedron by click stopping. Now 18.51, back to the jitterbug. That's when we go, this is 20, and when I squeeze it down a bit, you can imagine the missing links there that would make it an icosahedron. I'll insert icosahedron picture right there. Okay, and so that's the 18.51 station stop, and then we're up to yield 20. So that's a kind of a weird looking structure there, isn't it? That's what we call a generator in the Python language. Now that's kind of a mutant looking one, but it's nevertheless it's a generator. And I'm going to show you how it works. I'm going to save it as jitterbug.py, jitterbug.py, and now I'm going to hit the green arrow, which is going to run the thing, and nothing really happens. We just, blank canvas, we're still in a blank canvas. That's because this is just the definition of a generator that we could now use if we feel like it. It's like a tool in the toolkit, but we haven't actually picked it up yet and said, hey, I want to use this. So let's say I do want to use it. I'll call it bow tie equals jitterbug. I'm just calling it. Now, the way a generator works is, okay, now you have a generator object, it says. It doesn't actually, like a function, run to return at this point. A function would eat what you passed it, if there's anything to eat, and start barreling through code and try to hit a return or somehow fall off the end. So functions just run. But generators, they hand you back something that's now primed for action. It's like at the starter gate, ready to go. And so the way you make it go is you actually feed it to next, or you hit it inside a for loop, because a for loop is actually hitting the next of any object. So we go next bow tie, and it comes back with 20. So you see where this is going. Every time I go next, it proceeds to the next yield, picking up where it left off. So we kind of like ratchet our way through this program down to 1, and we don't pause at 0. We go through and come back out, and there's a tetrahedron. 2.5 is a 1/8 of a volume 20 cube octahedron. Octahedron, icosahedron, and back to cube octahedron. So that's pretty much what I wanted you to see. Some geometric, this can be meaningless to you. It doesn't have to have some deep physical significance. The fact is, you can do it. You can make this and do it out of sticks, and you can see that there are different volumes involved, and they're easy to remember, 1 and 4 and so forth, 20. So it's easy to remember. That's the thing. And then I want to show you a Python generator and give you a sense of what they can do. So there's more to generators, there's more to the Jitterbug, but that's enough for today. See you next time.